here's the bad thing. Yesterday's video had no talking on it, so I'm going to try to play it and talk my way through it today. I won't have to write it, but I'll be able to talk. This is problem 61. 100 minus 4x over 3 is equal to 5x plus 6 over 4 plus 6. So the first thing we want to do as we're looking at this problem is we want to see what number can all of their denominators go into. So I have 3 on the bottom and I have 4 on the bottom, and so I need to find a number that both 3 and 4 will go into. So the first number that both 3 and 4 will go into is the number 12. So what I'm going to do is I'm going to multiply every term by 12. Alright, so 12 times this term, 12 times this term, and 12 times this term. So the first term, when I multiply it by 12, the 3 cancels with the 12, making it a 4. 3 will go into 12 4 times. So that becomes, we'll do that in a second. 4 will go into 12, 4 will cancel out, and the 12 will become a 3. And over here, nothing cancels because there's nothing on the bottom. So now that I've simplified it, it's 4 times 100 minus 4x equals 3 times 5x plus 6 plus 6 times 12 is 72. So now I just have to distribute, and I get 4 times 100, which is 400, minus 4 times 4x, which is 16x, equals 3 times 5x, which is 15x, plus 3 times 6, which is 18, plus 72. Alright, combine my like terms. On the right over here, I'm going to get 15x plus 90 by putting 18 and 72 together. I subtract 90 from both sides, and that gives me, and I'm going to add 16x to both sides. So the 16x's cancel on the left, and I'm left with 310. And then on the right, the 90's cancel, and I get 31x. Divide by 31, and my answer is going to be x is equal to 10. And that works because there's no denominator in the problem. Alright, on to problem 63. Now, problem 63 looks like a proportion that you've probably seen before. It's a single fraction on the left and a single fraction on the right. And so the way that we've solved proportions is by doing cross products, and you're going to do the same thing here. So I'm going to multiply 3 times 5x minus 4 and set that equal to 2 times 5x plus 4. So now I distribute. 3 times 5x minus 4 is 15x minus 12, and 2 times 5x plus 4 is 10x plus 8. Subtract 10x from both sides, and add 12. And on the left, the 12's cancel, and I get 5x. And on the right, the 10x cancel, and I get 8 plus 12, which is 20. Divide by 5, I get x is equal to 4, which will work. I can plug 4 into the bottom of that fraction. It's not going to make it 0. So that's the only thing you have to check and make sure is when you get an answer, if you were to plug it back into the denominator, would it make that denominator equal to 0? Alright, problem 65. 10 minus 13 over x equals 4 plus 5 over x. Alright, so looking at the denominators, I have an x and an x. So I think I can multiply everything by x, and that'll get rid of my fractions. 10's over nothing, 4's over nothing, so the only things I have to worry about are the 13 and the 5, which are both over x. So I'm going to go through and multiply everything by x. 10 times x, 13 over x times x, 4 times x, and 5 over x times x. So 10 times x is just 10x, and then the x's cancel, and I get minus 13. And then 4 times x is 4x, and then the x's cancel, and I get 5. So add 13 to both sides, and subtract 4x from both sides, and I get the 13's cancel, so I get 6x on the left, and the 4x's cancel, and I get 18 on the right. Divide by 6, x is equal to 3. Alright, problem 67 is 3 plus 2 plus 2 over z plus 2. Now, z plus 2 is my only denominator, and I need to multiply by that. And I could do that now, But really what's easier is since there's a 3 and a 2, the easiest thing to do is go ahead and move that 2 over with the 3. And it becomes 1 equals 2 over z plus 2. If you didn't do that, if you went ahead and multiplied everything by z plus 2 to start with, it's fine. You'll get the same answer, but it makes it a little bit easier to go ahead and subtract and combine like terms. So I'm going to multiply both sides, or every term, sorry, by z plus 2. And on the right it cancels, which just leaves me with 2. And on the left, 1 times z plus 2 is z plus 2. So solve that and I get z is equal to 0, which again is okay. I can check it back out. If I were to plug it back in, it's going to make that denominator 0 plus 2 on the bottom, which is fine. Okay, problem 69. X over x plus 4 plus 4 over x plus 4 plus 2 is equal to 0. So looking at the denominators here, I have x plus 4's on the bottom, so that's what I'm going to multiply by. So x plus 4 times that term, x plus 4 that term, and x plus 4 with the 2, and x plus 4 with the 0. So the first term, the x plus 4's cancel out, and you just get an x. I'm having to wait on my video from yesterday. I don't know what I was talking about at that point in time. And then with the second term, the x plus 4's cancel out, and you get just 4. And then 2 times x plus 4 would be 2x plus 8. And then 0 times x plus 4 is just 0. Combine your like terms, you get 3x plus 12 is equal to 0. Subtract 12, you get 3x equals negative 12. So you get x is negative 4. But let's check it out. If x were to be negative 4, could you have a solution? No, because negative 4, if it was in the bottom here, you'd be dividing by 0. So you can't have an x value that's negative 4. So that's no solution. Because negative 4 plus 4 would be 0. And make it negative 4 divided by 0 if you were to try that problem. So that's what knocks it out. All right, problem 71. 2 over x minus 4, x minus 2 equals 1 over x minus 4 plus 2 over x minus 2. So looking at this, I know going into it that x can't be 4 and x can't be 2 because both of those will be dividing by that. Okay, sorry, I got interrupted. I'm back with 71. So we have 2 over x minus 4 times x minus 2, 1 over x minus 4, and 2 over x minus 2. So looking at this, I'm going to need to have an x minus 4 and an x minus 2 in order to cancel every denominator. And so I'm going to write x minus 4, x minus 2 with every term. And for the left side of the equation, both of them cancel out, leaving with just 2. Here I get the x minus 4's to cancel, so I have 1 times x minus 2, which is x minus 2. And here the x minus 2 cancels, and I get 2 times x minus 4, which I'll distribute that in the next step. So I get 2 equals x minus 2 plus 2x minus 8. Combine my like terms, I get 2 equals 3x minus 10. If I add 10, I get 12 equals 3x. Divide by 3, and I get x is equal to 4. But x can't be 4 because of the bottom of this fraction. If x was 4, then I'd be divided by 0. So x can't be 4, so my answer to this equation is no solution. Alright, problem 73, moving right along. 1 over x minus 3 plus 1 over x plus 3 equals 10 over x squared minus 9. And what I've got to do here is I've got to factor x squared minus 9. So I'm going to rewrite this, and I write 1 over x minus 3, 1 over x plus 3, 10 over, and then instead of x squared minus 9, I factor it. It's a difference of squares, so x plus 3 and x minus 3. And that's how it factors. So looking at my problem now, if I were to multiply by both x plus 3 and x minus 3 on every term, everything should cancel out. So I'm going to multiply the first term by x plus 3 and x minus 3. X minus 3 and x plus 3. I'm going to multiply the second one by x minus 3 and x plus 3. And the last one by x minus 3 and x plus 3. So the x minus 3's cancel out. 1 times x plus 3 is x plus 3. The x plus 3's cancel out. 1 times x minus 3 is x minus 3. And here they both cancel out, and I just get 10. Combine your like terms, you get 2x equals 10. So x is equal to 5, which will work for this problem. It doesn't make any of my denominators equal to 0. All right, on to problem 75. I must have been explaining something really big with that. Okay, 75, 3 over x squared minus 3x plus 4 over x equals 1 over x minus 3. So the first thing I need to do is factor that first term. So if you look at x squared minus 3x, it has a factor. They both of those terms have x, so I can factor that out. And x squared minus 3x becomes x times x minus 3, and then everything else stays the same. So if I multiply by both an x and an x minus 3 for every term, I should be able to cancel all of my denominators. All right, in the first term, they both cancel out, and I just get 3, plus, here the x's cancel out, so 4 times x minus 3 is 4x minus 12, and then the x minus 3's cancel out, and 1 times x is x. Combine your like terms, 4x minus 9 equals x, so negative 9 equals negative 3x. And if you divide, you get an x is 3. But if you look back up to that part, x can't be 3 because then you'd be dividing by 0. So I have to again get no solution for my answer. All right, moving on to 77. Now 77 doesn't have any denominator, so you don't have to worry about that part of the no solution. But we do have some squares, so we're going to need to do FOIL, or the distributive property. So I write down x plus 2 twice, and then I'm going to write down x plus 3 twice. X plus 2 times x plus 2 is x squared plus 2x plus 2x plus 4 plus 5 equals x squared plus 3x plus 3x plus 9. So we get x squared plus 4x plus 9 on the left and x squared plus 6x plus 9 on the right. If I subtract x squared from both sides, it cancels. And subtract 9 from both sides, it would cancel. And I would just have 4x equals 6x. When now I can subtract 4x from both sides, and I get 0 is equal to 2x. Divide by 2, and I get x is equal to 0. If you go back to the original problem and check it out, it will work. 0 plus 2 squared will be 4 plus 9. It works. Moving on. All right. So for this one, I went ahead and FOILed it out. It's exactly like problem 77. The x plus 2 squared is exactly the same. So it's already FOILed here for us, and then the 4 times x plus 1 on the right is 4x plus 4. Just trying to save a little time here. Combine your like terms. If you have x squared and minus x squared, that cancels. So on the left, you just have 4x plus 4, and on the right, you have 4x plus 4. And when the left is equal to the right, that's back to the beginning problems where you said it was an identity. That means there's infinite solutions to this equation if the left looks exactly like the right. All right, last one, problem number 81. Problem 81, I hope we're moving there soon. Oh, that was it. So 81 through 87 we went through today in class. If you have any questions, let me know tomorrow. And I'll look forward to seeing you then. Bye.